We now discuss the solution of a problem from the section Differential Equations. The problem is related to solving a given linear differential equation. This question has appeared in the joint entrance examination main held on 29th June 2022 in the second shift. The given question is, let y is equal to y of x, where x greater than 1, be the solution of the differential equation x minus 1 multiplied by dy by dx plus 2xy is equal to 1 by x minus 1, with y at 2 is equal to 1 plus e power 4 by, in the denominator, 2 e to the power of 4. If y at x is equal to 3 is equal to e to the power of alpha plus 1 by beta e to the power of alpha, then the value of alpha plus beta is equal to, we are given a differential equation. This is the differential equation. Its a solution is y is equal to y of x when x, and it is given x greater than 1. And this differential equation together with this boundary condition y at 2 is equal to 1 plus e power 4 by 2 e to the power of 4. And that differential equation with this initial condition is to be solved, and then it is given y when x is equal to 3 as e to the power of alpha plus 1 by beta e to the power of alpha, required to find the value of alpha plus beta. Let us now discuss the solution of the problem in detail. We have this differential equation when x greater than 1. Now, since x greater than 1, x minus 1 is not 0, therefore we can divide throughout by x minus 1. Dividing this differential equation throughout by x minus 1, we get dy by dx plus 2 into x by x minus 1 into y is equal to 1 by x minus 1 whole square. Now how this is looking like? It is of the form dy by dx plus p of x into y is equal to q of x. In our example, p of x is 2 multiplied by x minus 1, and q of x is equal to 1 by x minus 1 whole square. Now, it is a first order linear differential equation. And to solve such a differential equation, we find its integrating factor. The integrating factor is given by e power integral p of x dx, and the general solution is given by y into the integrating factor is equal to integral q of x into integrating factor integrated with respect to x plus c, where c is the constant of integration to be evaluated later. So let's get back to our differential equation, and we find the integrating factor. That is equal to e power integral p of x dx. So e power integral, in our case p of x is 2 multiplied by x minus 1. So you can take out 2 out of the integral, and it will be x by x minus 1. That can be written as x minus 1 plus 1 by x minus 1. Now dividing x minus 1 by x minus 1 is 1 plus 1 by x minus 1. So that will be written as 2 into e power 2 into integral of 1 plus 1 by x minus 1 with respect to x. If you integrate, integral of 1 is x plus the integral of 1 by x minus 1 with respect to x is ln of x minus 1, and there is a 2 before all these things. So that will be equal to e power 2x plus 2 ln log of x minus 1. So integral of 1 is x, 2 into x, plus 2 into integral of 1 by x minus 1 is ln of x minus 1. And this is written as This is e power 2x multiplied by e to the power of 2 into ln of x minus 1. E to the power of 2 into ln of x minus 1 is same as e power ln of x minus 1 whole square, and e power ln of x minus 1 whole square is x minus 1 whole square. So this will be e power 2x into x minus 1 whole square. That is your integrating factor. Right. So we are ready now to compute the general solution. The general solution is given by y into integrating factor, this is the integrating factor, is equal to integral q of x, that is 1 by x minus 1 whole square, into integrating factor, this is the integrating factor with respect to x plus c. Now x minus 1 whole square cancels here on the right hand side. So you are left with the integral e power 2x dx plus c, that is equal to e to the power of 2x by 2 plus c. Right, this is the integral. So integral of e power 2x is e power 2x by 2 plus c. So the general solution that we got is y is a function of x, therefore we have written as y of x into the e power 2x into x minus 1 whole square is equal to e power 2x by 2 plus c, where c is to be evaluated with the given initial condition. That we will do it in the next slide. So that's our differential equation, and this is your general solution what we have obtained in the last slide. Right, to evaluate c, we are given the value of y when x is equal to 2 as 1 plus e power 4 by 2 e to the power of 4. So put x is equal to 2 in the general solution. So put x is equal to 2, then you will get y at 2 into e power 2 into 2, e power 4 into 2 minus 1, that is 1 square is 1, is equal to e power 2 into 2, e power 4 by 2 plus c. Got it. Got it. So y of 2 is 1 plus e power 4 by 2 e to the power of 4. That we write down here into e to the power of 4 is equal to e to the power of 4 by 2 plus c. E power 4 cancels. Here you will get 1 by 2 plus e power 4 by 2. So e power 4 by 2, e power 4 by 2 cancels, and you are left with c is equal to 1 by 2. So go back to the general solution and substitute c is equal to 1 by 2. Thus we get a solution that is called the particular solution. The particular solution is given by y of x into e power 2x into x minus 1 whole square is equal to e power 2x by 2 plus c is 1 by 2. So this we have written as e power 2x plus 1 by 2. That's your particular solution. Now we have given y, the value of y when x is equal to 3 as e power alpha plus 1 by beta e to the power of alpha, and required to find the value of alpha plus beta. So in the above particular solution, substitute x is equal to 3. Then you will get y of 3 is equal to e power 2 into 3, 6 into 3 minus 1 whole square, that is 4, is equal to e to the power of 2 into 3, 6 plus 1 by 2. Right. Now write down y of 3. Y of 3 is e to the power of alpha plus 1 by beta e to the power of alpha, and e to the power of 6, 4 into e to the power of 6, you send it to the right hand side. That will come in the denominator. So that will be e to the power of alpha plus 1 by beta e to the power of alpha, that is y of 3 is equal to e to the power of 6 plus 1 by 2 into, you send this to the right hand side, that will sit down in the denominator. That will be 4 2s are 8 e power 6. On comparison, what we will see is e power alpha plus 1, e power 6 plus 1, and e beta e power alpha 8 e power 6. So on comparison, what we see is alpha is equal to 6 and beta is equal to 8. And we are required to find the value of alpha plus beta. Therefore, alpha plus beta is equal to 6 plus 8, that is equal to 14. So the answer to this question is alpha plus beta is equal to 14, and that is the detailed discussion of the solution of the given problem from the section differential equations, and the problem is related to the linear differential equation. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.